Welcome to the last session of our Unit 1, and we're going to talk about the types and properties of solids. Basically, your solids have two types based on arrangement of atoms. No, we have your crystalline and your amorphous solids. So crystalline solids, a solid with particles arranged in a geometric pattern that repeats itself over and over in 3 dimensions. So basta may 3D geometric pattern si solid, automatic amorphous solid ito, no? Anong examples ito? Salt crystals, minerals, gemstones, and ice. So here we have galena, quartz, pyrite, topaz, amethyst. These are all examples of your crystalline solids. Okay, unit cells. The symmetrical three-dimensional arrangement of atoms inside a crystal is called the lattice. The smallest repeating unit of a lattice is called the unit cell. So basically, your crystalline solids, they have unit cells. So paano ba nag-work yung unit cells na yan? So ang pinag-uusapan natin, no, keep in mind, ang pinag-uusapan natin dito is the arrangement of atoms, the 3D arrangement of atoms. So another example of your crystalline solid is your table salt or your sodium chloride. Sodium chloride. So let us look how these atoms in sodium chloride are arranged. Actually, ang arrangement ng atoms ng sodium chloride is cubic. Ayan. Paano naging cubic? So, meron kang sodium plus dito. Sige, palitan natin yung kulay para mas makita. So, you have sodium plus here. Tapos, may chloride ka dito. Tapos, sodium ulit. Chloride ulit. And then, sodium ulit. Chloride ulit, and then sodium ulit. Ayan. So, as you can see, the opposite charges, no? They are somewhat bounded to each other. So, this is an example of a unit cell. So, sa inyong sodium chloride, ganito ang arrangement ng ating atoms. Ngayon, yung lattice natin, no? So, eventually, yung mga unit cells na yan, magpa-pile up yan with each other. So, that's how your molecules are arranged. Alright? Okay, next. So, we go to amorphous solids. So, kung si crystalline solid, may defined geometric arrangement siya. Amorphous solids, they do not have. These are just long-range ordering of particles. Anong examples niyan? Glass. Organic polymers such as your plastics, no? Polyethylene, that's your plastics. Polystyrene, and your rubber. So these are examples of your amorphous solids. Okay, so this table is just, what do you call this? A summary of the different kinds of solids based on their bonding, no? So ionic solids, these are positive and negative ions, such as in the case of your sodium chloride. And we have your metallic solids, metal cation surrounded by sea of electrons. Molecular solids, ayan, anong example niyan? H2O, carbon dioxide. So these are covalently bonded molecules. Network solids, diamond, graphite, quartz. Again, these ionic solids, metallic solids, molecular solids, and network solids, these are classification of your solids based on their bonding. Okay, so the last part would be on phase changes. So phase changes, this occurs when energy is added or removed from a substance. So ano ba yung mga phase changes natin? From liquid to solid, from solid to liquid, from liquid to gas. Ayan. Just a recap, no? So, phase changes are physical changes characterized by changes in molecular order. Ayan. Molecules in the solid phase have the greatest order. Bakit sila may pinakamataas na order? Kasi, di ba, sa solid, halos dikit-dikit sila, di ba? They are compressed. And those in the gas phase have the greatest randomness. Kasi, if this solid is converted to the liquid phase, medyo nagsaslide past each other na yung mga molecules niyan. And yung gas natin, mas malalayo, no? Yung particles natin sa isa't isa. So, your gas particles have the greatest randomness. Ayan. So, this is just a summary of the phase changes, no? As you increase the temperature, you convert your solid to gas. So, yung molecular order from solid to gas, nagdi-decrease. So, from gas to liquid, Kapag binaba natin yung temperature, mas tumataas yung molecular order. Tapos from gas to solid, mas mataas lalo yung ating molecular order. Okay. So with increasing temperature, mas tumataas yung randomness ng ating particles. Now we go to phase diagrams. So a phase diagram is a graph in which areas represent phases. Ayan, so sulat natin para hindi kayo malito. Areas represent the phases. And the curves represent equilibrium. So, kapag equilibrium, ibig sabihin nag-i-interchange yung ating phases, no? Walang nagdo-dominate na phase. See, for example, later we'll look into that na lang. Each area represents a range of temperature and pressure at which each phase is stable. So here, if you're going to look at this one, okay, so this one is one area, so that is the solid, and you have your liquid and your vapor. Ito yung ating mga curves, oh. Ito mga curves na to, this represents your equilibrium. So pag sinabi nating equilibrium, at this point, at this certain point, yung nagdo-dominate na phase is hindi natin masabi kasi si solid na interchange siya agad with liquid, tapos si liquid nagiging solid agad, nagpapalitan sila agad. Same goes here. So, in these areas, there is a specific temperature and pressure na stable yung ating phase. So, this one sa ating y-axis is your pressure and sa ating x-axis is your temperature. So, each point on a line, the phase diagram represents a temperature and pressure at which the two phases on either side of the line coexist in equilibrium. Ito yung in-explain ko kanina, no? Ito yung mga lines natin dito. Itong mga lines na ito. Okay. Next. So, the triple point is the temperature and pressure at which all three phases are in equilibrium. So, if you're going to look at this, nasan yung ating triple point? Ito po yung ating triple point, itong dot dito. So, at this point, si solid, si liquid, and si vapor, nagko-coexist sila together. Ayan. The liquid gas curve ends at the critical point where the liquid and gases become indistinguishable. Ayan. So, this one, at this point, this is the critical point. Hindi na natin ma-distinguish si liquid and si vapor beyond that. So, anong phase na ang nag-i-exist dyan? Beyond the critical point, ang nag-i-exist na lang dyan is the supercritical fluid. Yan, supercritical fluid. Okay. So, let's look at the phase diagram of water and carbon dioxide. So this is the phase diagram of your water and carbon dioxide. So, ayan. So, identify lang natin yung parts, no? Ito yung ating critical point. So, beyond that, ang nag-exist na dyan is our supercritical fluid. So, beyond, at this area, solid pa, no? Solid pa. Tapos, beyond this temperature right here, ayan, liquid na yung nag-exist. And then, beyond that point, vapor na. So, this is the triple point. So, this triple point is the temperature, no? Temperature at which nagko-coexist yung solid, liquid, and gas mo. Ayan. Okay. So, ganun lang din ito ulit. So, in-identify lang natin dito, no? Yung specific areas. So, kung titingnan nyo dito, the arrangement is always solid, liquid, and gas. Ayan, ganyan siya lagi. So, try to interpret the phase diagram, no? Given the following phase diagram, determine the following. Paki-identify yung ating triple point, critical point, normal boiling point, normal melting point. Ayan, using this phase diagram. So, I think that ends our lesson. Yes, that ends our lesson. Now, try this on your own. No? Please try the phase diagram on your own. Our next lecture will be on solutions na. So, I'll see you again on our next meeting. And should you have any questions, no, paki-post na lang sa ating discussion forum.